Hello, and I hope whatever point in time in the future it is when you're watching this, it's a pleasant one. Today I'm going to go over some of the simpler aspects of creating a solar design and doing the equations for it all inside of Excel. Uh, as you can see, I have a bunch of stuff laying out. Those are all notes with my equations. I have everything written down and ready to go. I'm a big fan of preparing yourself ahead of time. I even have a list of all my parts. Solar panels, inverters, charge controllers, what kind of bulbs. You're going to need the stats and the specifics on all of your parts too. So looking them up online and preparing yourself with all that stuff ahead of time is a humongous help. Otherwise, you're not going to know for example, the efficiency of whatever items you're using, the power rating of the panel, the battery amp hours. These are all things you need to know in order to function throughout your Excel spreadsheet. So that said, let's start with as you can see on this Excel spreadsheet, I've chosen two locations to work through. The first thing you're going to need to know is your total load wattage. I have here 200 watts. You're going to need to know how many hours a day to run the load, the inverter maximum power rating, the inverter efficiency, the charge controller maximum amp rating, the charge controller efficiency, the panel power rating, the system voltage except inverter output, your battery amp hours, and your solar radiation average for the worst month. Now, each one of these items, and let me hone in on this a little bit without shaking too much so you don't get seasick. There we go. You don't want these numbers to change. So what I did is, in the course of my equations, as you can see here, my inverter input power here, and up top it shows you in the toolbar my formula for it. You can see there's dollar signs in here. If you click in the middle of that and hit F4, it makes it a constant. It will never change. You can use that over and over again in your equations and it'll never change. Another handy thing with this, as you're doing your equations in this, and in this case for the inverter output in Flagstaff, Arizona, the inverter output is the total load wattage divided by the inverter efficiency. So in this case, you can see by what's highlighted here that it is column B 2 divided by column B 5. And they're highlighted and they're color coded. It tells you everything that you're doing as you do it. How many inverters do I need? Well, here's what I used. The inverter output and the inverter maximum power rating. So it's the input input power divided by the inverter max power rating. Now you can see here that I have ceiling before that. Any equation that you want to do starts with an equal sign. That tells Excel that you're doing an equation. Ceiling rounds it up. And you can see I have B15, a constant, divided by B4, a constant, comma 1, all inside parentheses. The comma 1 is telling ceiling that after this division is done, you want to round up to the nearest 1. Therefore, you end up with, let's see, 1 here as opposed to 0.9666523 or some random number like that. You're also going to need to know the amperage output of your charge controller. So let's see what we did here. Says it's B15 divided by B9. And by clicking on the equation, I've highlighted it. It's a system voltage inverter output and the inverter input power. So it's the inverter input power divided by the system voltage except inverter output. There it is. Got it right up, all there, right for you. Here I've rounded up, so I'm assuming that I need a whole number for some reason, and it is because I'm looking for the number of charge controllers needed. And I don't want to end up with 0.76 of a charge controller. So we're going to round up. You can see a new equal sign to do an equation. Ceiling and D15 divided by B6. D15 is my amperage output of my charge controller. And B6 is my charge controller max amp rating. About kilowatt hours. Kilowatt hours, let me scroll over a little bit. Sorry about the movement. Let's look at the equation. I didn't need to round here, so there's no ceiling. It's like B2. B2. Charge controller. B2 kilowatt hours. Total load wattage times 1 over 1,000 times how many hours a day we need to run the load. That comes across as B2 times 1 over 1,000 times B3, all in parentheses. And again, it's done that for me. Now, what is the purpose of keeping it at your numbers as a constant? Well, in this case, we're comparing. And in the case of comparing, you want things to remain the same. You want your items to remain the same. You want the same load wattage. You want the same hours a day to run the load. You want to keep things as much the same as possible, or it's not really a comparison. So that being the case, even though I have two lists here, you can see that the only thing that is different is the solar radiation average for the worst month. Here and here. You want those to remain the same because you want all your other items to remain the same. Your panel, your battery, everything. So that you can use it repeatedly in various equations without having to go and type and having it slow you down. And I've ended with my total cost. So I have my kilowatt hours, my batteries needed, how many panels are needed, and the total cost, which is just, as you can see here, I have my cost included. So you do, how many batteries do you need? So we're going to do this times the cost of the battery, and you're going to add them all together for your total cost. You can see the equation for the total cost here and everything that's highlighted. I hope the shakiness of my camera wasn't too distracting, and hopefully this is helpful, or at least a little bit informative to someone out there. Have a good day.